Hey guys, welcome to lesson 1.7. We're getting dangerously close to algebra here. We're going to talk today about exponents and order of operations. So let's get exponents out of the way first. You've done these before. The exponent is this little number up here, right? We call that the exponent. And then this big number down here we call the base. Now, let me just talk real quickly about how you write this. It's so tempting and so easy to get this mixed up when you're writing it by hand. So you're going to want to practice writing your base as a big number and then your exponent as a little number. And, we're used to, writing it on the line. So it's really hard to avoid the temptation to write your little exponent down there. You've got to write it up top like that. And so you just have to be really careful to practice that. The biggest mistake I see is people just getting sloppy and it turns that 3 squared or 3 to the second power into a 32. Okay, so you got to be careful with that. And the other thing that people do inadvertently, and it's so easy, is to say 3 squared is the same as 3 times 2. And that is not true at all. So you have to be really careful with that. So what does 3 squared mean, or 3 to the second power, 3 raised to the power of 2, all fancy ways of saying the same thing. What does this mean? Well, 3 squared means 3 times itself with 2 threes, because the 2 is how many 3's we're going to multiply together. So 3 times 3, which of course you know is 9. And it's really common when you're doing these, and algebra students struggle with this all the time, that if you're so focused on remembering what does that little exponent mean and writing it down and all this stuff, then you just kind of lose your head and forget that 3 times 3 is 9. So, or we're so focused in on that 2 that we did 3 plus 3 and we had 6. So that's something to watch out for. So it's best when you see an exponent to go ahead, at least for now, and just write what it means, which is that number, the base, that many times multiplied together, and then set that aside and just think about, okay, what is 3 times 3? Okay, so that's one thing that you're going to be doing. The other thing is just using exponents to make it easier to write problems out. So here's an example. We have 4 times 4 times 4 times 4 times 4 times 7 times 7. And how can exponents help? Well, we take all the numbers that are the same number, that are being multiplied together, and we just make it one number. So 1, 2, 3, 4, 5 4s are being multiplied together. So I'm going to write 1 4, and then I'm going to say there's 5 of them being multiplied together. That's 4 to the 5th power. Then I put a times sign for the rest of the problem, and the rest of the problem is I've got 2 7s being multiplied together. So I'll write 7 one time, and then a little 2 as my exponent. That means there's 2 7s being multiplied together. So that is how we simplify a multiplication problem using exponents. Okay, so my recommendation is when you have to actually simplify, you have to do the math, then you pull it apart and you rewrite it as 4 times 4 times 4 times 4 times 4. But that is how we would simplify or just rewrite it using exponents. Okay. That's all we're going to say about exponents, although they might show up on our example problems here. But now we're going to talk about order of operations. Order of operations, and you have probably heard this phrase, this mnemonic called PEMDAS. PEMDAS. And what does that stand for? PEMDAS stands for parentheses, exponents, right, powers, multiplication, that's times, and division, it's divide, addition, plus, and subtraction, it's minus. Now, here's the thing. PEMDAS says do all those things in this order. First this, parentheses, inside the parentheses, then this, all the exponents, and then this, multiplication, and this, division, and this, addition, and subtraction. However, we actually do the multiplication and division at the same time. Like we don't do all the multiplication first and then we do all the division. We do them both at the same time. And there's a piece to PEMDAS that everybody forgets to say, which is move from left to right. So from left to right. So we're going to do all the parentheses, everything inside the parentheses from left to right, then everything outside the parentheses from left to right. We're going to do all the exponents from left to right, and then we'll do all the multiplication and the division starting from your left to the right. So the first multiplication or division we come to going left to right, then the second one, and so on. And then we'll do all the addition and subtraction going left to right. All right. I don't have very many great examples here, but we'll see some. Here's a really simple problem: 17 minus 2 times 6. It's fun to try these problems, to try to do them wrong. Like, what if we just said, let's go left to right, but we didn't do the order of operations? What if we did 17 minus 2, that's 15, and then times 6? Well, 15 times 6, that is 90. So that's not following the order of operations. I did the subtraction first, and then I did the multiplication second. And when I did that, I got an answer that we'll see is incorrect. So let's do it the right way. So moving left to right, but we're going to do the multiplication first. The first multiplication we come to is 2 times 6. 2 times 6 is 12. And then we bring down the rest of the problem. The 17 did not get touched. The minus sign did not get touched. And now we have a new problem to do. 17 minus 12. Well, 17 minus 12 is 5. Write that here so it's a little bit more clear. And there we have it. There's the right answer. So notice that if I didn't have PEMDAS, if I didn't have the order of operations, then I wouldn't know for sure whether the answer is 90 or 5, and that's a huge difference. So order of operations is really helpful because it gives us a rule for telling us which operation to do first in a sentence, so that we don't need a whole bunch of other symbols to help us to know that. Like could have put a bunch of parenthesis signs in here to help me know which one I meant to do first. But the order of operations helps us to simplify things. Okay, let's do another one, and I won't bother doing this one wrong. We have parenthesis 7 squared minus 7 close parenthesis divided by 7. So notice that we have some stuff inside parentheses, and then we have some stuff going on outside the parentheses. The first order of operations, the P stands for do what's inside the parentheses. So I'm going to do all of the stuff inside first before I do the stuff outside. So 7 squared minus 7, there's two things. There's a squared, it's a power of 2, and then there's a subtraction. So I need to decide which one first. The order of operations tells me do the squared first, do the power first, do the exponent first. So I can do 7 squared, which is 49. So I can do that part. And then everything else that I didn't do gets brought down. So the parenthesis, the minus sign, the 7, close parenthesis, the divided by sign, and the 7. Now I'm going to look at the new problem here. I've got a new problem. It's now parenthesis 49 minus 7, close parenthesis, divided by 7. So I follow the rules. I say, okay, parentheses, so I do what's inside the parenthesis first, and then I'll do what's outside, and then I do all the exponents. Oh, there are none. And then I do all the multiplication and division. Well, I do all the multiplication and division left to right inside the parenthesis, and there is none. And then I do all the addition and subtraction inside the parenthesis, and there is some. That's 49 minus 7, which is 42. So I did 49 minus 7, but everything else has not been touched, so I leave it. I'll leave the parenthesis, I'll leave the division sign, I'll leave the 7, and now I'll keep on going. And you may be saying to yourself, well, we don't need the parenthesis anymore, and you're right, I don't, but I just need to be careful that I don't take away the parenthesis sign too soon. So I always want to just be a little bit careful with this. It doesn't hurt to have it there. 42 is as simple as it can get, so I don't need the parenthesis. 42 divided by 7 is 6, and there we have it. All right, one last one. Let me give you a complicated one here, and this problem, I want to show you all the operations that are going on here. So I'm going to say, start here, we've got a multiplication, we've got a subtraction inside parentheses, we have another subtraction outside parentheses, we have a power, a squared there, we have another, we have a subtraction, we have another power cubed, we have another subtraction, oh my goodness, and there's one more that I missed. Can anybody see which one I missed? Hey, why aren't you guys talking? Oh yeah, nobody's there. I'm missing this one right here. And we said on a previous recording that that actually means an operation, and it is division. But the big fraction bar means division, but it also means parentheses. It means you put a big old parenthesis or bracket around the top and around the bottom, and do each numerator and denominator first, like do them all first, and then do everything in the numerator, everything in the denominator, and then do that division last. Okay, so now let's go through and start picking out what we're going to do first. Well, order of operations says do what's inside the parenthesis first, and the only parenthesis is the 12 minus 7. So I'm going to write 12 minus 7 is, let's see, that's 5, right? So 5. I'll leave the parentheses just so that I don't confuse myself, and then I'm going to write everything else there. There was a 5 over here that's outside the parenthesis. There's a minus sign outside the parenthesis. There's a 4. Okay. And then the division bar, the fraction bar, the denominator, I didn't have any parentheses other than the whole denominator is like in one big parenthesis. Let's do that first. But I have a bunch of exponents, so I'm going to do those. 5 squared is 25. So I just did that one. And then 2 cubed is 2 times 2 times 2, which is 8. So I did that one. And then everything I didn't do, I bring down the minus sign, and the 10. Okay, now I have a new problem here. It's a lot easier than the old problem because it doesn't have that parenthesis with the subtraction problem inside it. It doesn't have all those exponents, but it still has a number of operations, and it might be helpful for me to just go through and point out what they are. There's a multiplication on top, a minus, a subtract on top. There's 2 subtractions on the bottom. So I'm going to do the multiplication on top first. Order of operations. 5 times 5 is 25. And then I'll bring down, that's 5 times 5, and I'll bring down the minus 4. I'm bringing it over instead of down. You get the idea. Now, on the bottom, since the denominator is separate from the numerator, so they're separate, they're not going to touch each other until the end, I can go ahead and do my order of operations. In the denominator, order of operations says go left to right, and we're going to do, all the exponents are gone, all the multiplication division is gone, so we're doing addition and subtraction, so we're going to do 25 minus 8, which is 17. And then that's 25 minus 8, and then I bring down the minus and the 10. Okay, can we squeeze one last one here? Nope, I can't. I'm going to rewrite it down here. So 25 minus 4 is the top, and that's 21. 17 minus 10 is 7. It's the denominator. And so notice I did all of the simplifying of the numerator, all the simplifying of the denominator. in this fraction looking thing. I'm thinking of it as a fraction, but it's really a division problem. It means 21 divided by 7. 21 divided by 7 is 3. And there we have it. Now, the good news for you is that all of the problems that you're going to face are going to come out pretty simple like this. So if you get an answer that's coming out with a bunch of decimals, or it's just not working out for you, it's not going in evenly, that's probably a clue that you just did something out of order. And go back and check. Of course, you're checking your answers in the back of the book, so you're always going to know if you got it right or not. But make sure you're doing that, because this is where people tend to start making mistakes big time when they're doing order of operations, because it's so easy to get mixed up on what you're supposed to do next. So take your time, check your work. Don't be afraid to do a problem 2 or 3 times, and don't be afraid to write the work out. Get it wrong, just put a big X, doesn't have to be scribbled, just put a big X through your work, and then try it again, start over again and try it again, because that's going to be a practice that we're going to use throughout pre-algebra and algebra 2 and pre-calculus and trigonometry and calculus. So you might as well get started now. Thank you so much for watching, and have a great day.